this video we're going to talk about Newton's method of finding zeros of a function. This is mainly to approximate zeros at a function when they're not a pretty whole number. So let's take this function. F of x equals x to the cube, x cubed minus 4x squared plus 1. So if we just try to plug in f of 0, we're going to get 0 minus, we're going to get 1. And if we plug in 1, we're going to get 1 minus 4 plus 1. It's going to be negative 2. So we see that from 0 to 1, the jump is too big, and it completely passes over 0, but we know that it passes over 0. Since this function is continuous, we know that there is a point in between 0 and 1 that passes over 0. So Newton's method will let us find that point. So for Newton's method, we use this equation. Xn plus 1 equals xn minus f of xn over f prime of xn. And we use a graph similar to this, or a chart. So it'll be the number of x, it'll be xn, f of xn, f prime of xn, f of xn over f prime of xn, then finally xn minus f of xn, f prime of xn. So one by one we go up, and we get closer and closer to our answer. So let's try to plug in, so first you have to start with a prediction, or guess. So we know that the 0 is between 0 and 1, so let's start with 0.5. And then we plug that into the f of x, the function, which is going to be this up here, so it's going to be 0.53 minus 4, 0.52 plus 1. And plug that into the calculator. It'll be about 1/8. We're going to do decimals, so we're going to do 0.125. And then f prime of x n, so let's find the derivative real quick. Of f of x, it's going to be 3x cubed minus 8x. And we plug in 0.5 for the x, so let me do that. We get negative 3.25. Alright, and now we put that under the 0.25 that we got. Okay, negative 0.038. 5. And then we take our x of n, and subtract what we just got. And now we're left with 0.5385. So it'll be our first iteration. Every time you do it, it's called an iteration. So now this number will be what we start with here. Alright, now let's just do that one more time. Alright, so here we got, barely have any space, negative 0.00377. And then for the f prime, we got negative 3.438. Then do the fraction. Negative 0.00377. So here we got another small number, very, very small number, 0.00109. And then we subtract it from our original problem. Our second fx of n. 385 minus answer. We got 0.5374. So x's, the last numbers will typically be very similar, but this is just a more accurate answer. So we'll start with this answer, and then we'll check it, and we'll plug it into our original function, see if it gets us anything close to 0. So 0.5374 cubed minus 4, 0.5374 and 0.5374 cubed plus 1, and we get 0.0000054. So that's pretty close to 0.